Good morning, good afternoon. Thanks for joining us today for a session on AI innovation in industrial asset management. My name is Errol Binda with Cloud Factory. I'm pleased to have with us today Tristan Rouillard, who's the VP of Machine Learning Solutions with Cloud Factory, and also Adam Petruszka, who's Director of Business Development with Abyss Solutions. So before turning it over to Tristan to get us started, just a little bit about Cloud Factory. Cloud Factory is a global leader in combining people and technology to deliver AI automation solutions. And the company's been around for over 12 years. We've been delivering solutions to over 700 companies globally with a workforce of over 7,000 data analysts and operating across several continents. So I'm really pleased to be able to introduce you right now to Tristan, and I will turn it over to Tristan.
Thanks, Errol. Yeah, I'll be brief. Before joining the Cloud Factory team recently, I was one of the co-founders of Hasty. It's a machine learning platform specifically oriented around vision. It's humans helping machines see the world. We do this by enabling adaptive and agile methodologies. We'll touch on that a little bit more later, I guess. And before that, I was working in the German manufacturing sector doing, quite a few projects related to the topic for today. So I guess sharing what we learned then. Thanks, Errol. Adam.
Hi, I'm Adam Petruszka with Abyss Solutions. Abyss was founded in 2014 in Australia. We've since grown to a global company, and so my experience beyond Abyss is working in the high-tech industry. So I spent a number of years at large high-tech companies, and my time at Hewlett-Packard, I actually spent a number of years helping commercialize technologies out of HP Labs. So I gained a lot of experience there with emerging technologies at times, such as Internet of Things, big data, AI and machine learning technologies. So I'm now applying a lot of what I learned back in those days at Abyss Solutions. So next slide. So Abyss Solutions, as I mentioned, founded in 2014. We're growing rapidly. We are now a global company, and we are leading the charge around inspection at scale in a number of different verticals. So our biggest verticals are energy and water infrastructure, but we're also playing in agriculture space and exploring other industries. We're all about getting complete insights to customers about the condition of their asset, and faster insights mean quicker realization of value in their maintenance programs. And ultimately, when they get to quicker insights and better delivery of maintenance, they end up with safer and healthier assets for their operations.
Right, thank you. So I guess I'll go through a quick intro on industrial asset management. The goal of this is more or less to just establish a common ground that we can dive into some of the topics that are on. So to start with, just the definition of what is industrial asset management. It's a continuous process of planning and controlling physical assets to minimize the cost while maximizing the reliability and availability of that asset. So the goal here is it's often distributed assets or assets in a single place where there's hardware that needs to be maintained. I guess that covers it really well. So at least now we know what we're talking about when we talk about IAM as a topic. So what's sort of underlying the global trend? Why is this a topic today? What has led to us talking about it in a webinar? There's a few sort of macroeconomic trends, if you will, that have aggravated a situation where we need smart solutions, ranging from, working through the list. There's an aging industrial and civil assets globally. So I think we've all seen it in terms of power lines is a common one, wind turbines, solar panels are all installed but aging and need to be maintained. With that, there's the change in job demands. The younger generation seem to be less willing to do those kinds of jobs, and there's less supply in many countries. I do believe this tends to be a first world issue, but it remains to be an issue where there are less and less people willing to do jobs like and maintain power lines. There's rising labor costs and limited skilled technicians and inspectors. So what I sort of mean by this is we've seen, at least in Germany, and talking from experience that I've got, to not sort of make too broad a blanket statement, there is an aging population of experts that know how to maintain a lot of these complex assets, who are at a stage where they're nearing retirement, and there seems to be little to no succession planning in terms of, say, apprentices that would be working underneath them to take over that responsibility moving forward. And I do believe that this is reflective of a fairly large global trend that is happening. On top of that, we have the growth in renewable energies and similar assets. Solar panels take up space. It's hard to get around that or get away from that. Solar farms also are things that, wind farms are things that also take up space and need to be maintained on an ongoing basis, and they are distributed, and it's not trivial to do this. So it's not only in traditional industries and, say, oil and gas, but new renewable industries have the same problem of having to be maintained. And then, not to mention the regulations and environmental policy. We are having mounting pressure to look after the planet we're on, and there's increasing scrutiny to do that in a proper way. So, the 5 factors combined mean that this is a critical topic to solve now and to do it well. And it's also something that needs technology to do it well. So, segue to the next slide, Errol, to talk about that technology. So, what is happening now that's unlocking this as a use case for us? There's 6 sort of major breakthroughs in the last 5 to 10 years that have made leaps and bounds, that are making this more accessible, affordable, and deployable than ever before. It's ranging from a few factors. We worked in Hasty is a vision AI company, and we work with cameras on a daily basis. The cost of a camera sensor and the proliferation or the distribution of those sensors is massive, where in the past it might have been a different sensor that someone would use to do a given job. The fact that camera sensors are simply so cheap these days, a lot of companies tend to switch to using vision for that. So that's created quite an opportunity in terms of having an install base to run these applications on. There's been massive improvements in machine learning tooling as well as the models. So models are improving on a daily basis, and machine learning engineers have a full-time job just keeping up with breakthroughs in techniques and methodologies. But not only that, it's also the tooling. Softwares are getting better. It seems to be following the same parallel as the DevOps world, where DevOps had fairly archaic tools to begin with, and then they get more sophisticated and easier to work with as time goes by. We have the same parallel in machine learning, just a few years behind. Drones and the range of drones, there's a lot of people there were companies that we dealt with in agriculture and power sectors simply didn't have the range they needed or the payload that they could put on a drone to be able to do these kinds of tasks. They are able to do that now, which means you can do these kinds of inspections, which is great. And then processes improvements. NVIDIA and Intel have both been releasing new chips that are just doing better and better work and have stronger and stronger processing power, which is, it's important. The sort of final one, I think, is the one that is the most elusive, which is the combination of people, tech, and process. I'll allude to it, well, I'll come back to this topic later on, but the process of how to do things and how to work with this technology and do it reliably is still being established, but it is almost there, and it means that people are doing this far more successfully than they were in the past, or teams are doing this far more successfully than they were in the past. And so we'll touch on that a little bit later on. How big is the market? Yeah, here's some research to say big and growing like hell, 15% CAGR. I guess it's also early days. A lot of the innovations in industry or technologies that are affected by this are still sort of coming up in that innovation adoption curve. where we might see those growth rates go up rather than down in the future, or likely will. Right, we're going to jump into a quick poll now just to get a sense for the room. So if you just take a second or two to answer. Thanks, Earl.
Yeah, appreciate if folks are interested, would love to get your feedback on this poll. The questions should be up in the tool. Questions, what phase are you at regarding adopting AI for industrial asset management? And there's 4 options there. Are you interested, learning, exploring? A. B, evaluating solutions. C, currently in trials or beta. Or D, have solutions in production. So we'll just give you a few more seconds to enter and be curious to see the results. All right, I see the results are up, and it looks like we've got a lot of interested, learning, exploring folks. So all right, I'd like to turn it over to Adam at this point in time. Adam? Sorry, Adam, you're still on mute first.
Sorry, I thought I'd click that. Okay, I'm going to talk today about a real-world case study in the oil and gas industry, where we're basically using the Abyss technologies for autonomous inspection. So next slide. Okay, so in the real world today, there are limitations with visual inspections that are done for, for asset integrity, asset management. One of the first things is that the inspections are performed by humans, and every human is different in their productivity, in their interpretation, their perceptions. And on top of that, let's face it, every human can have a bad day. So as a result, you end up getting different levels or different subjective interpretations of the condition of an asset. Additionally, these assets are so large that no one person can maintain the level of concentration needed to cover these assets in an accurate and effective way. In addition, some of these areas are very difficult to actually access on the asset, and this so that's another challenge. So as a result, most of the annual inspections that are done in the oil and gas industry cover anywhere from 10 to 20% of the asset in a given year. And then so they basically do kind of a rolling inspection over the years to get a complete picture of the asset. So as a result, maintenance programs are very conservative in how they address challenges. So, for example, any issues identified, they will go out and paint, sandblast and paint, the entire piece of equipment that was identified as having an issue, as opposed to targeting the paint campaigns to a particular piece of the asset. That's one example. Other issues or challenges you face is even with the rolling inspection, people still miss things. Things are not identified that can lead to downtime as well as accidents. And actually, one of our customers, when we did the first inspection, we found a damaged piping that wasn't due for inspection for another 2 years, and it was so far degraded, it was likely to lead to a loss of pressure containment and a spill on that particular platform. So that right there sold that customer on the use of the Abyss solution. All right, next slide. Okay, so this is the inspection process. So the first part of our process is to go out and capture the data on the asset. So we do that through scanning, through photogrammetry, visual, cameras essentially capturing the asset, as well as LiDAR, sonar. We have some underwater camera systems so that we can take images and inspect the health of an asset from subsea all the way to the top sides, especially in the oil and gas, offshore deep water world. We use a variety of vehicles, so ROV for subsea, aerial drones in some cases, for structures on high. We use terrestrial laser scanners with a human crew, as well as even sonar if the water conditions are too turbid for actual visual inspections. Then we take all of the data that's captured and stitch them together into a single model of your asset that has both the visual imagery as well as the point cloud from any LiDAR that we capture as well, and stitch that together into a complete model of your asset, essentially a digital twin. Secondly, we then analyze that data. So we first thing we do is we contextualize that data. So if I don't know if anyone's familiar with the digital twin today. If you have a digital twin, it's great. You can walk through it. You can see all the equipment on the asset. However, you can't identify easily what something is. Well, one of the benefits of our solution is that we contextualize. We basically will label and tag every pipe, every flange, every vessel, structure, structural members, rails, grates that are on an asset. So as you walk through and click, you can see what that asset or what that piece of equipment is, as well as any associated metadata you have around that asset. Its service class, how, what size piping, what's the corrosion allowance or wall loss allowance for that particular type of material, what the material is, etc. So when you're clicking through, you can get a better sense of what that asset is. Then what we do is we let loose our AI machine learning models, both computer vision, as well as some additional models we have that look at the topography of the point cloud to identify various damage class mechanisms that might arise in an offshore oil and gas platform. So external corrosion's the most likely, but we can handle other damage class mechanisms. And what we do is we then classify based upon the customer's rating system, heavy, moderate, and low corrosion. And then what we can do is, you see this image in the middle, we will mask those pieces of equipment, piping, etc., where that corrosion was identified. And we have achieved high accuracy levels. So severe corrosion we can identify at a 97% accuracy rate, moderate at 95%, and low at 92%. So those are quite high machine learning model results. So we've been very effective in identifying and providing value for our customers in that way. And then finally, what we do is we help our customers act. So we're integrating into their workflows, helping them prioritize the damage found by the AI models. And then we can help them identify the pieces of equipment, the structures, et cetera, with the highest level of damage, whether, so for example, in external corrosion, we would prioritize those pieces of piping or flanges or pressure vessels with the highest coverage of severe corrosion first. And then we can also do it by total corrosion of severe, moderate, and low. So then what they get is, here's my prioritized list of where the highest damage classes are. So then they can nominate these pieces of equipment for painting, for replacement at a very targeted fashion. So that's critical for us, is we're trying to get our customers insights faster and more targeted and more accurate. That's the other thing that I want to mention here is the computer vision and machine learning models follow a standard. So they're constantly, as they crawl through the imagery, they are not taking breaks, they're not getting distracted, they're 100% focused, and so you get an objective level of analysis that you typically don't see from human inspectors. And so ultimately, what we're trying to do is give them objective results that they can then target and optimize their spend on maintenance, fabric, or painting, fabric maintenance, such that they're optimizing their spend, and they are increasing the level of health and safety of their asset, their offshore platform. Okay, next slide. Next slide is a video. They'll give you a taste of how the Abyss product works. Okay, so that gave you a quick taste of kind of how our product works, and you can actually see how the corrosion masks were applied, the fact that we can then identify critical lines, that they need to address on that particular platform. Now, here's the actual inspection benefits that this customer obtained for, this customer has approximately 10 platforms in the Gulf of Mexico, and this is what they quantified, and this is working with their asset integrity engineers that have the budget for inspection. So this is where they quantified their benefits. There are other benefits over and above just these quantified benefits. But as you can see here, the key benefits are coverage of the asset. So typically they do 15% of the lines, or sorry, yeah, the lines per year, and then cover that over the course of about 6 years. So now we're getting 95% plus coverage of all the lines. And then when we do the inspection, instead of a visual inspection by a human, it's a computer vision, and then any inspectors that they have in the office can then walk through the model themselves and do a follow-up inspection based upon the results that were identified. Additionally, the biggest benefit for these folks were they reduced their inspection budget by 50%. And so that was a key benefit to them. And then one thing here that may not make sense for a lot of folks, but what they call POB, or persons on board. So there's a limited amount of space on these platforms to bring people out. There's a limited number of accommodations that they can safely have, or a number of people they can safely have on a platform. And that most of these platforms are running at a very high utilization of POB. So freeing up POB means that they can spend time, instead of sending inspectors out, they can have either production or engineering out there, maybe enhancing or upgrading the equipment on that particular asset, or even adding new risers, new lines and all to increase the production of that particular platform. So that's another thing. Now, from an unquantified benefit, what you'll see is this also leads to things like reduced helicopter flights. And a helicopter flight out to a platform in deepwater Gulf of Mexico can run $20,000, $25,000 per flight. So that's a significant savings over time. Plus, you end up with increased equipment uptime. You end up with reduced painting. So if you can identify the critical lines, and you can actually, in our tool, measure. So you have measurement capabilities. You can say, okay, from this flange over 20 feet, paint that, sandblast and paint that particular area of the line, but don't paint the entire line. So that then starts to save money on the actual painting, whereas today they say, go out and paint this line and paint the whole line. So that's another. Additionally, another benefit is when they're doing engineering work, when they're doing upgrades and adding equipment onto the platform, they typically send a team out, an engineering team, to examine and do some rough measurements to figure out if this equipment will fit, et cetera. They can actually do that visually in the Abyss model. So they don't have to send a team out offshore to eat up POB and helicopter flights, et cetera. So that's the quantified benefits plus the non-quantified benefits. Now, next slide. This kind of says it all from a end result perspective. So this customer, over the course of a couple of years, was able to reduce the risk of the platform. So if you look at the top, you'll see the red and orange, where they had pieces of equipment, lines that were in a bad state. And through targeted focus on those high-risk items, they were able to reduce the amount of critical items that they had to address, and then they could get to painting. And so you see at the end result, they had a much healthier platform, fewer lines that were corroded, fewer critical items. So then that means safer platform, more uptime, to essentially increase the economic throughput or output of that particular asset.
Excellent, great insight, Dana. Appreciate that. At this point in time, we'll run their second poll, and would love to get your insights on this question that we've got here. So the polls that should be coming up. What challenges are you facing getting your ML into production? Option A, getting a model to generalize to real life, dealing with the data shift. Option B, deploying models to multiple devices. C, creating accurate, clean training data sets. D, collecting relevant data. Or E, getting SMEs to work with your ML teams. So I see the results have already been pushed through. So I guess I'll turn it over to you, Tristan. Any comments on the results are showing that I guess A, C, and D are the top ones that were selected here.
Yeah, thanks, Errol. I guess the summary there is data. Data is hard. I don't think we're surprising anyone by saying that, but seems to be at least confirmed by the audience. Yeah, thanks. So just jumping through, talking about that, picking up on the topic, it's actually quite an apt intro to what I'm going to be talking about. But ultimately, before starting Hasty and after starting Hasty, we were involved in a ton of machine learning projects. I've seen over 100 various applications, a lot of them in asset management. And the goal here is to just share a little bit about what we've seen work, not work, some potential best practice that we've seen. So just setting the scene or the background for that. There was a hype in 2017, AI is going to eat the world, everything's going to be automated, machines will take all of our jobs. That didn't happen. The failure rate for machine learning projects is something that we've been grappling with for a long time. Yeah, when we started Hasty, the statistic we found in research was that 65% of projects fail. Then we found research later on in 2019 that it was 87%. We saw another research paper last year that said 85 or 89%, somewhere around there. So it seems to be perpetuating that it's just hard to do. It is changing, where we're seeing teams do it successfully and doing it successfully at scale, which is different than a POC. And Andrew Ng was famous about talking about data-centric machine learning in 2021. There was a big hype and a big topic for a while. It seems that that's sort of been accepted now that data-centric machine learning is a dominant approach over model-centric, and we'll talk a bit about that in the next slides, data-centric versus model-centric. You know, the point being that if you're not looking after your data and you're not curating an accurate, clean data set, you're not going to be successful. And you know, despite the challenges, we're still seeing 32% of companies invest in AI. So it seems like the problems we're solving are real. They're not going anywhere. How to do it is hard. What we need to do is start establishing best practice and reliable processes and methods to work with the technology. So hopefully we'll hint to that in the next slides. Thanks, Errol. So this is about data-centric, model-centric. So historically speaking, especially in research, machine learning teams tend to focus a lot on the model. That's because if you're doing research at Stanford, for example, you have a static data set and you're trying different machine learning models and approaches and methodologies to get the best performance on something that's static. So very common to use was COCO dataset, and COCO dataset was then a static data set, and everyone would benchmark the latest approach or technique against COCO and then publish the research paper to show how they've improved on previous research. And they were treated like two separate worlds. You know, we've seen that perpetuated to the corporate world, where we've seen large edge, cutting edge tech companies have a link between the training data and the algorithms or the machine learning team, which is email. The annotation team emails the training data to the machine learning team, which is an insane link, because at the end of the day, the algorithm reflects the data that it's been trained on. It's, you know, a bit more complicated than that, but by and large, it's a reflection of the data it's trained on. And those worlds need to be looked at in a more dynamic fashion. The interplay between them needs to be focused on, because it's really that interplay that makes this whole endeavor work and more exciting, is when you understand what the data is doing to the neural network and you understand how those two are relating to one another, that you start having fun in this. So personally, I don't love the arguments of data-centric versus model-centric, because I do see them as two sides of the same coin, and they should be treated as such. Thanks, Errol. With that in mind, this is a historical sort of approach that many teams would take when deploying machine learning applications. They would define a business case and a need. You know, in our case, it's maintenance of assets and reducing the cost to maintain those assets. And you'd then approach a machine learning engineer and say, how would you solve this problem? And they will design some sort of approach based on what experience or what they've done in the past. They collect images, label the images, QC the annotations, train a model, test the model, deploy the model, get into production, and then realize, oh, we defined our taxonomy incorrectly, where we were treating this thing as two separate label classes where it should have been one label class, or we should have added an attribute there, or we should have been in instance segmentation with masks instead of bounding boxes for object detection. And so they then have to go sort of back to the drawing board and start labeling data all over again. But that's only once they've tried to deploy the model. And that means this iteration cycle is often 3 to 7 months. And we could imagine that if you build software today with iteration cycles and feedback loops of 3 to 7 months, you would expect that team to fail. You're not iterating quickly enough. And specifically when we talk about iteration here and feedback, it's feedback from the model. You need to get feedback from the model to understand how the model is understanding the data. And that's what's sort of been missing in this approach. Thank you, Errol. So what we've done at Hasty is we've created an application where the model and the training data live in the same world. They live in the same environment. We actually annotate with the model, and we retrain the model based on what's being annotated. So what you're essentially building is a feedback loop or a data flywheel within the annotation environment, where the more data you label, the better your model gets. The more you can automate the annotation process, the more data you can label. And that's an accelerating virtuous cycle that we've created, where you've now got the opportunity to understand, are we getting automation? Is the neural network understanding the subject matter within the images? if it's not, you get immediate feedback that potentially your annotation strategy, what you're using to annotate the data, is potentially not optimal, and you can adjust in real time. The other side of it is we've got an application essentially where every project gets to the point where you don't know where the next performance step is going to come from. It might be, sorry, that you need to just label more data. That's common and often the case, but it also might be that you need to clean up what you've labeled in the past. Labeling data is a very manual process and notoriously error prone, which means that often those errors can hinder the performance of models, and you need to be able to clean that up. So we've got a flow for that where we've got neural networks that go back and check what's been labeled in the past to find potential mistakes so that you can clean it up. You might need to test a different model architecture. You might need to change a hyperparameter or augment the data in a different way. So one needs to be able to jump between these tasks a priori or ad hoc to find your next performance increase. But the other part of this that's very critical is to get to production, to actually deploy a machine learning model. You need to have a feedback loop where you can understand how the model is performing in the wild, and you can fetch instances in the wild or in production where the model hasn't performed, get them back to the beginning of your ML development flow, whether that starts with annotation, it probably does. Annotate the data, retrain the model to understand what it's now missed, and update and deploy a new updated version of the model. This is what we would then refer to as the data flywheel in production. It's the sort of gold standard or the holy standard what people are working towards. And in order to do that effectively, you need to have this annotate, train, deploy flow or pipeline, as it were, be as smooth as possible with as many or as few instances as possible. Thanks, Errol. So yeah, I guess I was foreshadowing this slide. Essentially, you've got two virtuous cycles that one wants to try and get in any typical data flywheel with humans in the loop at key points, right? You're going to get your data, you'll label that initially. That's obviously got a human in the loop, and you'll clean up that data. Deploy a model in the wild. Now, once it's deployed in the wild, the critical step here is to do inference monitoring in a smart way. So often it'll be done with a form of active learning where you can look at certain model metrics to understand how uncertain the model is about the inference that it's making. I would go beyond looking at confidence scores. That's a very dangerous approach that we see many teams do. Notoriously poor at being able to monitor inferences, but once you've then flagged an image and said, okay, this is something we're not understanding, you probably want to have some sort of human in the loop to review that, confirm it, and put it back into the development cycle to close the flywheel. And how smoothly you can get that flywheel to spin and efficiently will be the critical success factor that often determines whether or not a team will be successful in deploying machine learning. Mike Tyson had the quote where he said, everyone has a strategy until they get hit in the mouth. It applies here in the sense that your model will get hit in the mouth. You're going to deploy a model trained on a sample of data, which by definition will see things in production that it will not have seen on the sample that it was trained on. And it's not a question of if it will fail, it's when it will fail and what do you do about it when it fails. If you can answer those questions well and you can adapt to that quickly, you'll be successful in machine learning and deploying AI. Thank you. So what now? I guess the questions like next steps. I saw from the first poll there was a lot of teams interested and curious, like in starting their journey in the vision AI or in the AI world in general. Critical steps: identify workflows in your business that require experts to inspect something. So we work in vision. The hint that I always give teams is if you have somebody in your company that needs to go and look at something to make an assessment. So in the case we had from Adam, they would like to look at the wear and tear that's happening in the plant to visually understand, is there something that needs to be repaired? Okay, well, given that that's the case, so you want to look at a crop to visually understand certain things, the stage, the growth stage, or the disease in that crop, or anything that requires this visual information that is being assessed by experts in your company, you have something that potentially could benefit from Vision AI. You then need those SMEs. The person that's actually doing that work today is the person that you need to collaborate with and work with in order to train a neural network, because that is the person that understands, okay, if you're looking at this, what part of this is visually important to make the decision? And they need to then apply their judgment, and the judgment that needs to be translated into how you label the data, which then creates the training data you need to train the neural network. So working with those SMEs is an underrated step and very seldom done, actually. Extremely important. Pair them with a machine learning engineer where they can have this wonderful friction of, well, if we try to do it this way, would that work? No, that would not work because of this and this reason. And you need that back and forth between the subject matter expert, the machine learning engineer, and potentially other operational teams that are involved. And then look to how you can implement the system to augment the existing team. Very often, there's a question of what happens to the systems that are there today. You can't just replace them, because if you replace them, what happens with the failure? Who takes responsibility for the failure, et cetera, et cetera? I think it's too drastic a step. We often make the mistake of not looking at AI as an ally or a colleague, and look at it as a threat or a substitute. It won't be there to substitute. So even in the example of radiology, a lot of people say, oh, well, doctors are useless. They will be replaced by an AI. You don't need one to do a radiology assessment anymore. And it's not necessarily the case. In most use cases, they're augmenting the doctor to just either assess a larger sample of data and make a decision of that, or to augment what the doctor said. I think one of the KPIs they track is if you have a doctor that's given you assessment and the AI agrees, you're significantly less likely to go for a second opinion, and that's the KPI they track. But the company that's doing that is obviously looking at how can we augment our existing force with AI, and that's the mindset or the approach we need to have when working with this tech. Thanks, Sarah.
Excellent.
Yep.
Well, thanks,
thank you.
Tristan and Adam, for great insight, practical examples of how we're applying industrial asset management and AI to that. I'd like to encourage, if you've got any questions, to pop them into the tool here, and we'd be happy to answer those questions. Got some time. I see a Tristan question here for you. In shifting from model-centric to data-centric, how long of a process is this? Any guidance based on your experience on getting started?
The length of the process, I think, depends on the team. The number one advice we tend to give teams is, if you're the machine learning engineer, label data. A lot of machine learning engineers don't want to do it. It's not glamorous work. It's grunt work. It's hard to do. It's tedious. But it is critical. It's critical to build the empathy for what your neural network is required to learn. And in doing that, you tend to see edge cases and see, okay, yeah, maybe I didn't define this as well as I should have, or we can define this in a different way. So the first thing I would say is label data. The second thing is to invest in having a data asset that is clean and accessible. It's two components of a data asset that I think you could do an entire webinar just dedicated to that topic, but it's super critical for a team to have clean, accessible, relevant data to train neural networks on and gain insight from. So those would be the two main things.
Okay, great. Adam, we got a question here for you. Can you share an example of another industry you've been able to apply your solution to outside of oil and gas?
Certainly, there's actually two industries. One is the water infrastructure space. So we've actually done projects in basically ports, marine terminals, inspecting underwater pilings, the underside of docks, the level of the docks, as well as any cranes and all up above the dock, and build models and damage class assessments for that. So that's one industry. We've also been working in the agriculture space. So actually, I'm involved with one right now with a rice farm that has thousands and thousands of acres under cultivation. And we are working to do several flyovers with drones early on when the plants are first sprouting to count this, what they call stand counts. So how many plants are actually germinating. If there's areas of fields where they don't seem to be coming through and germinating, they can go out and improve the watering, they can increase fertilization in those spaces. And then the follow-up as the plants get larger, do flyovers, periodic flyovers for weed detection. If there's certain weeds that are growing that can be detrimental to the crop, they need to know where they are and send people out to remove those weeds. So those are two other industries in which we're playing with our kind of computer vision, machine learning methodology.
It's great to hear. Definitely lots of applications, and even more so right as we move forward.
Yeah, and one thing I'll follow up there, just to kind of emphasize what Tristan said, is the subject matter experts in that industry are critical. So we have data scientists, that very smart people. They know nothing about rice farming, nothing about marine terminals. So working with our customers, as well as we've even hired on board some subject matter experts ourselves from those industries, so that we can actually build relevant applied machine learning models that solve specific problems. So these aren't academic exercises, these are economic exercises to produce value for our customers.
Yep, makes a lot of sense. Tristan, this question here. There are multiple research papers reporting high failure rates, like up to 87% mentioned here. For those projects, what are common causes for this, and how does one mitigate, I guess, those causes?
Yeah, thanks, Errol. I guess the challenge or complexity that comes with implementing a system, and a system that needs to learn on the job, which it does. I think the past approach was train a neural network or an AI till it gets 100% accurate, and then when it's 100%, you deploy it, or as good as possible. And you try and build a silver bullet and deploy a silver bullet, and silver bullets don't work, especially not in this world. Whereas now there's deep understanding for the data flywheel, as mentioned earlier, and that you need to deploy a system that's adaptive, which has components in it that I think are heavily underestimated. It's not train, deploy, and forget. It's train, deploy, and monitor, feedback, improve. And that train, deploy, monitor, feedback, improve as a workflow is often not taken into account, to teams' detriment. That's one. And the second one is, I guess, something that I alluded to earlier was, a lot of machine learning engineers have an unenviable task. This is a new industry and a new field with new neural networks, new forms of annotation, new ways of doing things, and they're defining an approach up front by their best guesstimate, frankly. And we're then looking back at that and iterating on that, potentially too slowly, but also sometimes as you see teams that get a bit defensive about their approach because I guess you get painted into a corner to some degree. I think there needs to be a bit of a comfort and an empathy for the machine learning engineer that there is just limited experience, and we need to be okay that these approaches will evolve over time and they're going to change. An annotation strategy and your taxonomy is probably wrong when you first start. We spoke to a team, I guess I can mention this, the Team Planet. They do a lot of satellite imagery. they said that they iterate on their taxonomy in a fundamental way at least 7 times before getting close to something that looks representable. So that's like how you define your label classes and your attributes and what you're actually looking at. They changed that 7 times, and that's a very experienced team who knows what they're doing. So I think, yeah, just create room for experimentation in the beginning and be understanding and empathetic with that would be the other one.
Excellent. So I don't see any other questions. I guess any final words. Over to you, Adam. Any parting thoughts or additional?
I mean, I would just reemphasize that, ultimately we're about providing economic value. So, I think a lot of these machine learning AI projects that fail also don't necessarily bring in that subject matter expert and fully understand the value proposition for a particular application well enough to prove that there's true economic value. And so it's become, again, it's a science project. So I know everything we do when we engage with customers is really drilling down, really investigating, what their challenges are, what's the economic value of solving those challenges before we then engage in trying to build models or build solutions that address those problems.
Excellent. Tristan, any last thoughts? Or?
No, just to say I'm really impressed with what Abyss is doing. It looks really fantastic. They have the 3-step process that they showed at the beginning, which each one of those steps could probably be a company in its own right, and they're doing all 3 and seem to have stitched it together beyond 1 but 3 industries. It's really, really awesome to see. Congratulations.
Excellent.
Thank you.
Well, Tristan, Adam, really appreciate your time and participating in our webinar today. And for the audience, thank you for taking the time to participate, and appreciate your feedback on how this went. Thanks, and have a great day, everyone.
Thank you.
Cheers.